Do you want to do math?
No!
Do you want to do math?
No!
Hey, do you want to do math?
No.
Do you want to do math?
No.
Hey, do you want to do some math?
No?
Do you want to do math?
Yeah, I want to do math.
Today we're going to teach you about graphing and interpreting quantitative data sets with stem and leaf plots and dot plots.
You're also going to learn how to graph and interpret data sets using pie charts and Pareto charts.
And then you're going to learn how to graph and interpret paired data sets using scatter plots and time series charts. In other words, class.
You are going to graph a line.
So we're going to start with stem and leaf plots.
In a stem and leaf plot, the numbers are separated into a stem,
No!
which are the leftmost numbers, and a
No!
leaf, which are the rightmost. The first thing you need to make a stem and leaf plot is a lot of data. The data goes from a low of 78 to a high of 159, so the stem values should be from 7 to 15, and those are the numbers on the left of the plot.
So then the entry 155 would have a stem of 15 and a leaf of 5. And don't forget to include a key. That's a stem and leaf plot. You learn something new every day.
To make a dot plot too. In a dot plot, each data entry is plotted using a point above a horizontal axis.
No.
A dot plot lets you see how data
Here,
is.
reread that way. In order to make sure each number from the data is included, the horizontal axis for the set of data includes all numbers between 70 and 160. To represent a data entry, a dot is plotted above a number on the horizontal axis. And if there are repeats of numbers in your data, just plot it above all the other dots.
Yeah, I want to do math.
Now you have to learn about pie charts. Pie charts are circles that are divided into sections to represent categories.
What's a pie chart?
A lot of times people generate pie charts in computers.
But sometimes you can just draw them like this.
Of course I want to do math.
Oh.
Moving on. Another way to graph qualitative data is by using a Pareto chart. Pareto charts are vertical bar graphs in which the height of each graph represents the frequency of relative.
The bars are positioned in order of decreasing height, with the tallest bar positioned at the left, which helps highlight important data and is used a lot in business and professional things.
Finally, you need to know about graphing paired data sets, and you need to know how to graph them using scatter plots and time series charts.
Scatter plots show the ordered pairs graphed as points in a coordinate plane. A scatter plot is used to show the relationship between two quantitative variables.
A data set is composed of quantitative entries taken at regular intervals over a period of time. It's called a time series. For example, the amount of precipitation measured each day for 1 month is a time series. And you use a time series chart to graph a time series.
It's really good. Do you feel like you can graph now?
Yeah.
No!
Yeah.
Today we'll also be learning about binomial distributions.
First, we'll learn how to determine if a probability experiment is a binomial experiment.
A binomial distribution that satisfies a binomial experiment satisfies 3 conditions. The experiment has to be repeated for a fixed number of trials. There's only one of 2 possibilities, and which can be classified as either a success or a failure, and the probability of success has to be the same for each trial.
Have the best worst video. And the random variable x counts the number of successful trials.
Now we'll go over the notations for
Do you wanna do
binomial
math?
experience.
N is the number of times the trial is repeated. P is the probability of success in a single trial. Q is the probability of failure in a single trial. X is the random number that represents a count of the number of successes in n trials.
This is a binomial probability formula.
This is a binomial probability table.
No!
These are different ways to find binomial probabilities.
Now we'll begin learning how to graph binomial distributions.
First, make a frequency distribution for possible outcomes.
Then find the sum of the frequencies.
With each possible outcome by dividing its frequency by the sum of the frequencies and check that the probability is between 1 and 0 and that the sum of all probabilities equals 1.
And that's all, folks. Hey, do you want to do some math?
No.